Have you ever had one of those moments where you're staring at your phone, waiting for a web page to load? You've got full signal and nothing's happening. This kind of sucks, right? I mean, this site could be the best thing ever, but if it takes too long to load, I'm going to get bored and I'm just going to go do something else. Now get this. You have about 1 second before a user starts to get distracted. 1. So what causes a site to have slow load time, and how do you fix it? My name's Matt Grunt. I'm a developer advocate, and I wanted to talk to you about PageSpeed Insights, a tool which can be used to find issues affecting your site's load time and give you some tips on how you can fix them. So when you visit PageSpeed Insights, you bash in your URL and it'll give you a score out of 100 and highlight any problem areas with your site. The focus of this tool is to point out issues which, if fixed, would improve your site's overall load time and make your users happier. The big question is, what do you do with this information? Well, the most common problems fall into 3 buckets. First, problems that can be solved with build tools. For example, JavaScript files where you could minify them and send less bytes down the wire. Or merging multiple files, so rather than make 4 requests, you only make 1. The second set of issues are focused on the structure of your page. For instance, where you link to your JavaScript files. And thirdly, problems which need server-side tweaks to enable things like caching of your page assets. Let's start off with looking at build tools. Many of you may already be using some kind of build tool today, but if you aren't, then I recommend checking out Grunt or Gulp.js. These build tools are picking up a lot of steam within the web development community, and they're fairly easy to get to grips with. The main reason you'd want to use a build tool is to automate any set of tasks you're going to run on your project on a regular basis. And most build tools will allow you to pull in third-party modules, which means you get a lot of stuff for free. So let's look at a basic example like JavaScript minification and concatenation. In other words, take some JavaScript files, strip out any white space, replace variable names with shorter ones, and then just squish all the files together. This way, our JavaScript file is smaller, making it faster to download, but the browser also has fewer files to download. To achieve this, you can use the uglify task. You define which files to minify and merge, and it just takes care of it for you. CSS min and HTML min will do the same thing for CSS and HTML. Another common problem area is image optimization. When you run PageSpeed Insights, it looks at your site and basically checks whether any of the images are larger than they need to be. And in the guidelines, it will recommend JPEG Optim, which is a command line tool which strips out any metadata from the image files and can lead to some really impressive reductions in file size. And when I say it strips out metadata, I mean things like which camera was used to take the photo. It's not needed for a browser to render the image, so just get rid of it. So to add this to your build process, use ImageMin for raster images and SVGmin for vectors. And SVGmin will strip out white space and any unnecessary tags and attributes from your SVG files. The second set of problems falls into the category of page structure. Now, I don't know about you, but I've definitely put a JavaScript file in the head of my page before. The problem with this is that the browser will start to parse the document, and as it reads the HTML tag, the head tag, it'll eventually reach your script tag, and this is where you'll see the screen of bad times. Nothing. The reason the page stops rendering is because JavaScript can manipulate the DOM and CSS. So the browser needs to go and fetch the JavaScript from the server and execute it once it's downloaded. This is just in case the script changes the DOM or CSS. And it's only after the JavaScript has finished executing that the page can continue rendering. So to avoid this delay, simply move your JavaScript to the bottom of the body element. This way the browser can parse and render the page up to this point, and then it will handle fetching the JavaScript at the very end. An alternative and slightly more performant technique is to use the async attribute. Now what async does is it tells the browser to download and execute the JavaScript asynchronously, avoiding the render block. The reason it's slightly more performant is the browser doesn't need to wait on the DOM and CSS to be loaded before it can execute the JavaScript. But you need to be careful, because it means you can't rely on the DOM, CSS, or any other JavaScript file to be loaded by the time your JavaScript actually executes. Essentially, it might require you to think a little differently to how you use JavaScript depending on what you're doing. The second page structure woe is CSS. When we add a CSS link tag, the rendering of the page will block much like it did with JavaScript. We'll see it step through the HTML tag, into the head, reach the CSS, and boom, we'll hit the sad screen of nothing. The browser has no choice but to do this. It has to download the CSS before it can style anything. Otherwise, the user would see unstyled content followed by just a flash of all the CSS as it's loaded and everything is styled. The fix for this can be quite involved, and there's a lot of caveats, each with their own pros and cons. If you have a relatively small amount of CSS for a page, you can inline it directly into the HTML, removing any request for a CSS file and allowing the page to be rendered as soon as the HTML is loaded. If you have a large amount of CSS, however, you could inline just the above the fold CSS so the browser can render the most important content, and then load the rest of your CSS using JavaScript. The obvious downside of this approach is that it requires JavaScript, meaning if it's switched off, you won't get the additional styles. With both inlining techniques, you also lose the ability to cache the CSS files, which could be a big loss if you have styles shared across multiple pages. In which case, it might be worth splitting out the styles to CSS files so you can cache them, and inlining any unique styles for each page. Ultimately, test it and see what works best for your site. The final element of the page load gotchas is server-side tweaks. Jumping straight in, let's look at caching. When the browser makes a request for a file from your server, it should always return a cache control max age header. This is what tells the browser to cache a file and for how long, meaning the next time your user visits your page and it needs a file, it doesn't need to download it again. It's just good to go from the cache. When it comes to caching, there are a few things you need to ask yourself. First, how long can I cache my files for? Second, how do I actually get my server to return this cache control max age header? And thirdly, what do I do when I need to change a file? Answering the first question of how long do I cache my files for, I personally found HTML5 boilerplate to be a good source of guidance. If you look at HTML5 boilerplate's HD access file, there are a number of caching rules defining the caching period depending on the type of file. Here's a snippet of the file. We've got CSS and JavaScript cached for a year, images are cached for a month, and HTML isn't cached at all. Now this is just a guideline. You may want to cache your images for a year, you may want to cache your HTML for 30 minutes to an hour, just so that any user hopping backwards and forwards between pages gets a smooth experience. If you're using Apache to host your site, then you can just use this HD access file to implement the caching rules. If you're using a different server, then check out the documentation on how you can add these headers. Now, chances are you're going to want to change some of these files before the cache expires, in which case consider adding a build step to revision your file names. This way there won't be any issue with older versions of files being used. FileRev is an example task designed specifically for this use case and can even be used with other modules to replace file names in your HTML and CSS, so it's pointing to the revision file. The final thing to enable on your server is gzip. If you've not come across this before, it's supported by all browsers and it's an incredibly powerful tool for compressing any text-based assets. There are some huge wins to be had with compression rates of up to 80%. Now, how you enable this will depend on your server, but the gains are big for a relatively small amount of work. I recently got this working on my Nginx server, and it was as simple as just adding gzip on. So those are the three most common problem areas raised by PageSpeed Insights: build time fixes, page structure, and server-side tweaks. Now these aren't the only tools to help with performance. So if you're looking for more tips or just curious about what other tools exist, I strongly recommend checking out this blog post by Adi Osmani. It includes many of the tools mentioned in this video in much more detail. Hopefully this has been a useful insight into how you can improve your site's load time performance, and I challenge you to get 100 points on your PageSpeed score. Cheers.